In example B, we are still solving systems of equations with 3 variables and 3 equations. This one's going to be a little bit more difficult in part A though, because in part A, we were told specifically what one of those variables equaled. We were told that Z equaled -2. While this one looks very complicated, and it is a little bit more complicated than part A, it's still nothing that we haven't done before. If I take away this top line here, this is what we did last lesson in lesson 4 when we solved systems of equations with 2 variables and 2 equations. So now all we're going to do is we're going to solve for y and z here. Once I have y and z, then I'm going to do what I did last step and do back substitution. We'll plug in our y, we'll plug in our z, and then we'll get our x. So it's really just one additional step, and that one additional step is very easy and straightforward. So if I'm focusing on these bottom 2, multiply one of them by a negative. It doesn't matter which. I'm going to multiply this top one by -1, but you get the same result if you multiply the bottom one by -1. So now this equation here, changing every sign, is -y plus 2z equals -1. We need to remember to multiply that constant. And so these are stacked. I'm just going to bring this one over. Okay. So we're using elimination. Probably should have started with that. We're using elimination method. Substitution would have actually been very easy as well. But the goal is to get one of these variables to eliminate. So -y plus y goes away. Another name for elimination is addition. So now add what is left. So 2z plus 7z is 9z. And -1 plus 10 is 9. So we've got z equals 1. Now I need to get another variable. We're going to substitute back in. It doesn't matter which equation you use. You just can't use the top one, because if you substitute z or 1 in for z up here, you still have 2 unknowns, right? So we're going to use one of these bottom 2. Doesn't matter which. I've already used I'm going to use this bottom one right here. So if I have y plus 7 times z, which we found to be 1, equals 10. So that is y plus 7. Subtract that over and we get y equals 3. So now I know what z and y equals. Now we can get our answer for part A. My brain's not connected to my mouth today. We can get our answer for what x equals. So now I'm using that top equation because that's the only one where x is. And so I have x minus 3y, which was 3, plus 5 times z, which z is still 1. That equals -6. So solve. So I've got x minus 9 plus 5 equals -6. That is x minus 4 equals -6. So x equals -2. Okay, now in my math lab, it's going to ask specifically, what does x equal? What does y equal? What does z equal? But I like these as ordered pairs. So this is -2, 3, 1. That is your final answer for me on your test. And so this is always x, y, z. I have 2 notes down here. The first note says, we will not get into 3-dimensional graphs in this course. However, the solution we found to the system of equations still represents the same thing as it did in 2 dimensions. The solution is the point at which the graphs intersect. So for a fun visualization of this, click on this link. So you can either type that in, or if you have the PDF version, just click on that. And so I already have that pulled up for us. When you click on it, here it is. And so you can see that solution is that 2, 3, -1. That's that point. When I have variables, when I have an equation like this with 3 variables, this makes a plane. And so you can see we have the blue plane, green plane, pinkish red plane. And what's cool is you can kind of just drag this around and move it around since it's in 3 dimensions. And so this point right here is where those 3 planes all intersect. So that's something you can kind of play with, if you would like to. But that's really all I have for lesson 7.1. For 7.1, says solve all problems for 7.1 by using what is called the RREF command in Desmos. So you need to continue on to lesson 7.2 to learn more about this RREF command. And so you will be using this RREF command for both homework sections of 7.1 and 7.2. So you shouldn't be doing any of these hard ones. Now, if it's one like this where you have 2 variables and 2 equations and you can solve for one, you can do that by hand. But anything else, when you get to problems that look more like this right here, where you have 3 equations of 3 variables, and every one of those 3 equations has 3 variables, you should not be doing any of these by hand. You're going to be using this RREF command. So go to the next lesson to learn about how to use that.